You are blind, hairless, and about the size of a jelly bean. You've just been born after only 33 days inside your mother's womb, and now you're facing the most dangerous journey of your entire life. You need to climb through a forest of fur, find an opening you can't see, and reach safety before your underdeveloped body gives out. Welcome to the first 3 minutes of life as a kangaroo, and what happens next will completely change how you see one of the world's most recognizable animals. The moment you emerge into the world, you're essentially still a fetus. Your back legs are just tiny buds that can't move. Your eyes are fused shut and won't open for months. But here's what scientists discovered in 2025 that changes everything we thought we knew about this journey. Your front limbs, despite being smaller than a grain of rice, contain specialized muscle fibers that are proportionally stronger than an adult human Olympic weightlifter. Researchers at the Australian National Wildlife Research Centre used micro-CT scanning technology to map the muscle density in newborn joeys and found something extraordinary. These temporary climbing muscles are designed to work exactly once for this single journey, and then they completely restructure as the joey develops. You start climbing immediately, using a swimming motion through your mother's fur. She's standing upright, which means you're climbing vertically against gravity with a body that weighs less than 1 gram. The air temperature outside the pouch is dropping, and you have no fat reserves and no fur to keep you warm. Your core temperature is falling by the second. This climb needs to take less than 5 minutes, or you won't make it. But here's where the story gets even stranger. Your mother doesn't help you. She can't reach down and guide you, and she won't lower her body to make the climb easier. This seems cruel until you understand what scientists learned about kangaroo reproduction in recent genetic studies. Female kangaroos can pause pregnancies, carry embryos from different fathers at the same time, and produce 2 different types of milk simultaneously for joeys of different ages. The climbing test isn't cruelty. It's the first natural selection filter. Only joeys with the strength and directional instincts to complete this journey have the genetic foundation to survive what comes next. You reach the pouch opening and tumble inside. The temperature immediately jumps by 15 degrees Celsius. Inside, you find 4 teats, but you can only attach to 1. This is critical because kangaroo milk changes composition over time, and each teat produces a different formula depending on how long it's been in use. You latch onto one, and within seconds, it swells inside your mouth, creating a biological lock that keeps you attached even while your mother hops at speeds up to 70 kilometers per hour. If you're enjoying this deep dive into kangaroo science, hit that like button and drop a comment telling me which animal you want covered next. We're just getting started, and what happens over the next few months is going to blow your mind. Inside the pouch, you're living in one of nature's most sophisticated portable incubators. For the next 6 months, you won't let go of that teat. You'll feed continuously while your body completes the development that most mammals finish inside the womb. Your eyes will form and open. Your fur will grow in. Your bones will harden, and your legs will develop the spring-loaded tendons that make kangaroos the most energy-efficient travelers in the animal kingdom. But scientists didn't expect what they found next when they studied pouch environments using fiber optic cameras in 2024 and 2025. The inside of a kangaroo pouch isn't just a simple pocket. It's a self-cleaning, climate-controlled ecosystem with its own microbiome. The pouch lining produces antimicrobial secretions that prevent bacterial infections. The mother can control the temperature inside by adjusting blood flow to the pouch walls. And here's the part that shocked researchers. The pouch contains specialized bacteria that don't exist anywhere else in nature. These bacteria help pre-digest nutrients in the milk, making it easier for the underdeveloped joey to absorb proteins and fats. Even more fascinating, genetic analysis revealed that these pouch bacteria are passed from mother to joey and play a critical role in developing the joey's immune system. Joeys raised in captivity without exposure to natural pouch bacteria show significantly higher rates of digestive problems and immune deficiencies later in life. This discovery has completely changed how wildlife rehabilitation centers care for orphan joeys. At around 6 months old, you're finally ready to see the outside world. Your mother will start leaning forward periodically, encouraging you to peek your head out of the pouch. The first time this happens, the light is overwhelming. Your eyes have developed in near total darkness, and suddenly you're experiencing sunlight, colors, and depth perception all at once. You duck back inside immediately, but over the next few weeks you'll spend more time looking out, watching how your mother grazes, observing other kangaroos in the mob, and learning the body language that will keep you alive. Kangaroos have a complex communication system that scientists are still decoding. They use over 16 distinct vocalizations, foot-thumping patterns that can communicate different levels of threat, and ear positioning that signals mood and intention. Here's something most people have completely wrong about kangaroos. They're not just mindless grazers hopping around the outback. Cognitive research published in 2025 demonstrated that kangaroos can learn and remember complex spatial maps, recognize individual humans even after months of separation, and solve multi-step puzzle boxes at rates comparable to dogs. One study at the University of Sydney showed that kangaroos could intentionally communicate with humans by alternating gaze between a sealed container with food and a human observer, essentially asking for help. This is a behavior previously thought to be unique to domesticated animals. At 7 months old, you're too big to fit comfortably in the pouch with your sibling, but you're not ready to be independent. This creates one of the most fascinating and heartbreaking dynamics in kangaroo development. Your mother will start forcibly removing one of you from the pouch to make room. This isn't random. She's making a calculated decision based on size, strength, and developmental progress. The stronger joey gets priority access because they have a better chance of survival. If you're the one who gets evicted, you'll spend days following your mother, trying desperately to climb back in whenever your sibling leaves. But your mother will physically block you, pushing you away with her paws. This seems harsh, but it's essential. The pouch can only support one joey at this stage, and trying to accommodate both would compromise the development of each. During this transition period, you're at your most vulnerable. You're too big to hide in the pouch, but too inexperienced to detect danger quickly. This is when predation rates are highest. Dingoes, wedge-tailed eagles, and increasingly, feral cats and foxes target young kangaroos during this awkward stage. Conservation data from 2025 shows that predation by invasive species is now the leading cause of joey mortality in eastern Australia, surpassing natural predators by a significant margin. The wedge-tailed eagle deserves special attention here because it's one of the largest eagles in the world, with a wingspan that can exceed 2.3 meters. These eagles hunt using a technique called contour flying, where they use terrain features to hide their approach until the last possible second. When your mother thumps the ground as a warning, she's not just alerting you, she's communicating to the entire mob, and the vibrations travel through the soil faster than sound travels through air. Kangaroos 100 meters away can feel the warning before they hear it. But here's where the story gets even more interesting. Recent behavioral studies show that kangaroos have different thump patterns for different threats. A rapid, continuous thumping indicates an aerial predator, like an eagle. A slower, intermittent pattern signals a ground predator like a dingo, and a single, sharp thump means, pay attention, something's not right. This is language. This is complex information transfer that requires learning and cultural transmission within the mob. By the time you're 1 year old, you're functionally independent, but you'll stay with your mother's mob for protection and social learning. Kangaroo mobs aren't just random groupings. They're structured societies with dominance hierarchies, cooperative defense strategies, and information sharing about food and water sources. Young males like you will start testing boundaries, engaging in play fighting that looks gentle, but is actually training for the brutal combat that will come later. You'll rise up on your tail, balance on your hind legs, and exchange soft kicks with other juveniles. These practice sessions are critical. Kangaroos that don't engage in play fighting during their juvenile phase show significantly lower success rates in adult competition and mating. The boxing behavior that kangaroos are famous for isn't just for show. It's one of the most sophisticated combat systems in the animal kingdom. Adult male kangaroos can deliver kicks with a force exceeding 750 kilograms per square inch. Those kicks are powered by the same spring-loaded tendons that make kangaroos such efficient hoppers. The Achilles tendon in a kangaroo's leg can store and release elastic energy like a biological spring, and during a fight, all that stored energy gets released in a single devastating strike. But scientists discovered something unexpected about kangaroo fighting in 2025. High-speed camera analysis revealed that the most successful fighters aren't the ones who kick the hardest. They're the ones who feint and misdirect. Dominant males use head movements and shoulder shifts to make opponents commit to a defensive position, then strike from an unexpected angle. This is strategic combat. This is tactical thinking in real time. At 2 years old, you're entering the most dangerous phase of your life. You're big enough to challenge other males, but not experienced enough to win consistently. This is when mortality rates spike again, not from predators, but from injuries sustained during fights. Broken ribs, punctured lungs, and deep lacerations from claws are common. Some males die from infected wounds days or weeks after a fight ends. Water access becomes a critical battleground during drought periods. Australia experienced one of its most severe droughts on record in 2023 and 2024, and the impact on kangaroo populations was devastating in some regions. Dominant males control access to shrinking water sources, and younger males face an impossible choice: challenge for access and risk injury or death, or leave the area and search for water elsewhere, which means traveling through unfamiliar territory filled with predators and hazards. Climate research published in early 2025 projects that these extreme drought events will become more frequent and more severe over the next 2 decades. Kangaroos are already adapting. Researchers have documented behavioral changes, including increased nocturnal activity to avoid daytime heat, expanded home ranges as animals search for resources, and changes in breeding patterns, with females delaying reproduction during resource scarcity. Here's something that will surprise you about kangaroo thermoregulation. When temperatures exceed 40 degrees Celsius, kangaroos lick their forearms. But this isn't just cooling behavior. The forearms contain a dense network of blood vessels close to the skin surface, and when saliva evaporates, it cools the blood flowing through those vessels. That cooled blood then circulates through the body, reducing core temperature. It's essentially a biological air conditioning system, and it's so efficient that kangaroos can maintain stable body temperatures in conditions that would be lethal to most other mammals of similar size. They also dig shallow scrapes in the soil to reach cooler earth beneath the sun-baked surface. These scrapes become communal resources, with multiple kangaroos using the same cooling spot throughout the day. Thermal imaging studies show that the temperature inside these scrapes can be 15 to 20 degrees cooler than the surrounding surface, which can mean the difference between survival and heat stroke during extreme weather events. At 3 years old, you're finally ready to compete for mating opportunities. You've reached your adult size, your muscles are fully developed, and you've learned enough from watching other males to have a fighting chance. But here's what most people don't understand about kangaroo mating. It's not just about winning fights. It's about reading social dynamics, choosing your battles carefully, and knowing when to back down. Female kangaroos have more control over reproduction than almost any other mammal. They can pause embryonic development if environmental conditions aren't suitable. They can terminate pregnancies if resources become scarce, and they actively choose mates based on criteria that go beyond simple size and strength. Recent studies show that females prefer males who demonstrate strategic thinking, who win fights efficiently without taking unnecessary damage, and who show appropriate social behavior within the mob structure. This is sexual selection driving cognitive evolution. Smarter males get more mating opportunities, which means intelligence genes get passed to the next generation at higher rates. Over thousands of generations, this has produced an animal that's far more mentally sophisticated than most people realize. But kangaroos face challenges that have nothing to do with natural selection. Human activity has dramatically altered the Australian landscape over the past 2 centuries. Habitat fragmentation from agriculture and urban development has isolated kangaroo populations, reducing genetic diversity and limiting access to traditional migration routes. Vehicle collisions kill thousands of kangaroos every year, with some estimates suggesting over 10,000 deaths annually in high-traffic areas. Here's where conservation gets complicated. In some regions, kangaroo populations are declining due to habitat loss and climate change. In other regions, populations have exploded because humans eliminated natural predators like dingoes and created artificial water sources for livestock that kangaroos also use. This has led to controversial culling programs that wildlife managers argue are necessary to prevent overgrazing and starvation, while animal welfare advocates push for non-lethal alternatives like fertility control. The science is clear on one point. Ecosystem balance requires predators. Areas where dingoes have been eliminated show not just higher kangaroo numbers, but also changes in kangaroo behavior. Without predation pressure, kangaroos become less vigilant, more sedentary, and ironically less healthy overall. Predators don't just control prey numbers, they shape prey behavior in ways that benefit the entire ecosystem. Conservation programs in 2025 are testing innovative approaches. Some areas are reintroducing dingoes in controlled corridors. Others are using drone technology to monitor population health and movement patterns in real time. And researchers are developing non-invasive fertility control methods that could provide alternatives to culling in areas with overabundant populations. One of the most promising developments is the use of artificial intelligence to predict and prevent vehicle collisions. Smart road systems in parts of Queensland and New South Wales now use thermal cameras and AI recognition software to detect kangaroos approaching roadways and activate warning lights for drivers. Early data suggests these systems reduce collisions by up to 60% in equipped areas. But perhaps the most important conservation work is happening in education. For decades, kangaroos were viewed as pests by many Australians, particularly in agricultural areas where they compete with livestock for grazing land. That perception is slowly changing as people learn about the ecological role kangaroos play, their cultural significance to Indigenous Australians, and their value as a unique part of Australia's natural heritage. Indigenous Australians have lived alongside kangaroos for over 60,000 years, and their traditional ecological knowledge offers insights that Western science is only beginning to appreciate. Traditional burning practices, for example, create a mosaic of habitat types that support diverse kangaroo populations and reduce the risk of catastrophic wildfires. Collaborative management programs that incorporate Indigenous knowledge with modern conservation science are showing remarkable success in areas where they've been implemented. If you've made it this far, you're clearly fascinated by animal science and conservation. Do me a favor and subscribe to the channel so you don't miss future videos. We're covering everything from deep-sea creatures to apex predators, and I guarantee you'll learn something that changes how you see the natural world. Let's talk about one more aspect of kangaroo biology that deserves attention: their immune system. Kangaroos rarely get cancer. In fact, cancer rates in kangaroos are significantly lower than in most mammals of comparable size and lifespan. Research teams in Australia and the United States are studying kangaroo genetics to understand why, and what they're finding could have implications for human medicine. Kangaroos have multiple copies of certain tumor suppressor genes that humans only have single copies of. They also have unique immune cell types that appear to be more effective at identifying and destroying abnormal cells before they become cancerous. This research is still in early stages, but it represents exactly the kind of unexpected benefit that comes from studying and protecting biodiversity. We never know which species might hold the key to solving human health challenges. As you grow into a fully mature adult kangaroo, you'll face one final challenge: passing on your genes to the next generation. If you're a male, this means years of competition, strategic fighting, and social maneuvering. If you're a female, this means making careful decisions about when to reproduce, which males to mate with, and how to give your joeys the best possible start in an increasingly challenging environment. The kangaroo life cycle is a masterpiece of evolutionary engineering. From that terrifying first climb as a jelly bean-sized newborn to the complex social dynamics of adult life, every stage is optimized for survival in one of the harshest environments on Earth. These animals aren't just survivors. They're innovators, constantly adapting to new challenges with a combination of ancient instincts and surprising intelligence. The next time you see a kangaroo, whether in a documentary, at a zoo, or in the wild, remember that you're looking at an animal that has been refining its survival strategies for millions of years. You're seeing the result of countless generations of natural selection, an animal that can pause its own pregnancies, produce custom milk formulas, survive in extreme temperatures, and communicate complex information through ground vibrations. Kangaroos are living proof that nature's solutions are often more sophisticated than anything humans could design. They're a reminder that every species has a story worth telling, and that the more we learn about the natural world, the more we realize how much we still have to discover. These animals deserve our respect, our protection, and our continued curiosity about the secrets they still hold.